Alright guys, welcome to this page of the notes, and what we're going to do is continue developing these methods of factoring polynomials to help us find the zeros of a polynomial. And the next one that we're going to look at is known as the sum and difference of two cubes, and hopefully what you recognize here is this one's a lot like some of the other ones we've looked at, where you're just simply trying to match it to a couple of formulas that you've been given. The first one is for the sum of two cubes. The second one is for a difference of two cubes. And excuse me, when you look at the problem, if the polynomial that you've been given fits either the sum of two cubes or the difference of two cubes, then you just simply apply the formulas that you've been given right here. Now, again, the only thing I really can point out about this, it'll make a lot more sense as I do some example problems with you, but it's just you want to be really careful about your signs here. If it's a sum of cubes, right, when you get back here to the trinomial, it'd be a minus plus, and if it's a difference of cubes, when you get back here to the trinomial, plus plus. Again, it'll just take some practice doing these problems, getting used to the formulas. It just takes practice. And of course, flashcards are a great way to memorize these formulas. Write the difference of cubes on the front of the flashcard, write what it's equal to on the back of the flashcard, and just keep going through those both directions until you've got these formulas just sort of down pat. Difference of cubes is pretty popular, and so you're going to see it a lot, homework quizzes, things like that. So let's jump right into this and do a couple of these guys. Now, when it comes to perfect cubes, I'm certainly not going to make you memorize any perfect cubes, guys. That's what you've got a calculator for. Your calculator, if you have the TI, the Texas Instrument, a graphing calculator, an 84, an 86, something like that, the calculator will have a math button on it. It's a math function. And when you select that math button, it'll be over on the far left-hand side, up near the top, just below the screen. It'll say math right on it. Once you click into that math function, option number 4 is going to be a cubed root operation, and what it'll do is it'll allow you to take the cube root of numbers. That's a real quick way that you can use your calculator to check to see if a number is a perfect cube, right? So I go ahead and I go into that math button, I hit that math button, I select option number 4, my calculator drops a cubed root into the screen, I plug in a 27, I hit enter, and I quickly find that 27 is a 3 cubed, right? So 3 times 3 times 3 gets me 27. So 27 is a perfect cube. I do the exact same thing. Math, option number 4, which is a cubed root. I plug in an 8, and when you take the cubed root of 8, you get a 2, which means 8 is a perfect cube. 2 times 2 times 2 gets you 8. So what I've got here is, actually, sorry, I slid too far right there. There's my formulas. So what I recognize then, real quickly, is that if I do a 3a and cube it, right? The property of exponent says you cube the 3, which gets me 27. You cube the a, which gets you an a cubed. Then I just figured out that if I cube a 2, 2 cubed gets me 8. And so now what I've got, this guy right here matches this one, right? Because it's subtraction, where 3a is my a and 2 represents my b. So this guy fits that bottom formula, and so now all I need to do is just apply the rest of the formula. I know it's going to be a minus b, 3a minus 2. And then the rest of the formula is an a squared. Well, that's a 3a. So 3a squared. And then plus a times b plus a, which for me is a 3a, times b, which for me is a 2, plus b squared. Well, my b is a 2, so I'll do a 2 squared. And now, guys, all you need to do to get your final answer is just take care of any properties of exponents that show up in there. So 3a minus 2, and then I have square everything inside the parentheses. Since it's a product, right, you just square everybody inside the parentheses. 3 squared is a 9. a squared is an a squared. 3a times 2 would be 6a. And of course, 2 squared is 4. And so what I found is that by doing this, by figuring out that this was the difference of perfect cubes, I can use that difference of perfect cubes formula to factor my polynomial, right, into two factors. My first factor is a binomial, my second factor is a trinomial. And let's try another one of these just to make sure you guys are okay with it. This one's going to be a plus, so I'm going to lose my formula for a second. You guys can see it there on your page on the notes. So here we go. Once again, I use my calculator. I click into that math option, choose, or math operation, choose option number 4, and do the cubed root of 64, which turns out to be a 4. So I know that I can write this as a 4x cubed. 4 cubed is 64, x cubed is an x cubed. And 125, again, using your calculator, you'd find that 5 times 5 times 5 gets you 125. So I would do a 5 cubed, because 5 cubed gets me 125. Okay, so here we go. It fits this definition right here. I have an a cubed plus a b cubed. I slid a little bit. I don't know if I can get them both on there so you can see them both. It's going to be tight. Right here, my a cubed, my b cubed, right? So this guy right here fits that top formula. So let's go ahead and apply the rest of the formula. I know that it's going to be an a plus b. So my a is 4x. My b is a 5. Right, that's my a, that's my b, so it's a plus b. And then the next part had a minus sign and then a plus sign in it, right? So right up here, I'm going to do an a squared minus a times b plus b squared. So let's go ahead and do that. I know that I need an a squared. Well, my a is a 4x, and I'm going to square it. Then it's going to be minus a, which again is a 4x, times b, which for me is a 5 in this problem. And then I'm going to have plus a b squared, which for me is, again, a 5. All right, let's go ahead and take care of any properties of exponents that I've got going on in there. Okay, 4x, I just square everybody inside the parentheses, so 16x squared. Negative 4 times 5 is going to be a minus 20x. And 5 squared is 25. And so again, what I found is that this guy is it fits the definition for a sum of perfect cubes, right? The sum of perfect cubes. And so I use the rest of the definition to factor this sum of perfect cubes into its factored quantities, a binomial and a trinomial. Guys, head on over to the next page of the notes. We'll try a few more of these. Again, they just take practice first to get used to the formulas and then applying them. So I'll meet you over there.